You know that feeling, maybe you're stuck in a meeting or you're in a line at the DMV that just will not move, and you get this really heavy sense of déjà vu.
Oh, man.
That feeling of, I have been here before. I have done this exact thing before, and I am never, ever leaving.
It's the horror of the mundane, right? The idea that today is just a photocopy of yesterday.
Exactly. And culturally, we have a very specific shorthand for that feeling. We just call it Groundhog Day. It's become the ultimate time loop story.
It really has.
But we have a stack of sources today that are going to pull the curtain back on two completely different sides of that whole time loop idea.
It's a really fascinating pairing. On one side, we are looking at the original script notes and the production logs from the movie Groundhog Day.
The 1993 classic.
Right. And they reveal a much darker, almost disturbing story compared to the comedy that we all know and love.
And on the other side, we're slamming that right up against hard physics papers. We're talking Einstein, special relativity, some pretty wild new studies on entropy to ask the question, is the loop actually possible?
So it's Hollywood magic versus the cold, hard laws of the universe.
So what's our mission here? What are we trying to figure out in this deep dive?
I think we're trying to explore the gap, to see how fiction uses time travel to talk about regret and, human behavior, while physics uses it to test the absolute boundaries of logic and causality.
Okay, so let's start with the cultural anchor. Groundhog Day. I think everyone knows the premise. Bill Murray is Phil Connors, a cynical weatherman stuck in Punxsutawney, Pennsylvania.
Wakes up, it's February 2nd, goes to sleep.
Wakes up February 2nd again. But looking at these original script notes from Danny Rubin, the movie we know is not the movie he wrote.
Not at all. Danny Rubin's original vision was much more in media res. It started in the middle of things.
Right. In the final film, you see Phil's normal day first. You see him being a jerk to his cameraman. You see the van ride. You get the setup.
But in the original script, it opened with Phil already trapped.
Yeah, this part honestly blew my mind. The script literally starts with him checking out of his hotel. The concierge asks if he's leaving, and Phil says, chance of departure, 100%.
So confident.
He walks out, and then boom, he's right back. The loop hits him. You don't get the backstory until way, way later. It feels so much more claustrophobic.
It forces you, the audience, to feel the trap immediately. And the tone was just significantly darker. The movie opens with those nice shots of clouds, right?
Very cinematic.
The script opened with groundhogs in a dark burrow. And there are scenes in Rubin's draft that show a Phil who has moved way past, whimsical mischief into something bordering on, sociopathic boredom.
There was one scene in the notes that I actually had to read twice. It's the library scene.
Oh, yeah.
In the movie, I remember he's there reading poetry, trying to impress Andy McDowell. It's all very romantic.
Right? Part of his whole self-improvement montage.
But in Rubin's original draft, Phil walks into the children's room of the library, and he pulls out a shotgun.
Yeah, it's jarring.
He tries to shoot the groundhog inside the library. That is not a Bill Murray comedy. That's a horror movie.
It is. And that's the disconnect. Rubin wasn't writing a rom-com. He was writing a story about a man who has completely lost his mind. In the script, he's already read every book in that library. He's exhausted the world.
And the librarian just calmly mentions that the glass is bulletproof.
2 inches of bulletproof glass? You can't be too careful in this day and age.
Wow.
It highlights the absurdity, but also the sheer desperation. Phil isn't just a grump anymore. He is a man who has exhausted every single possible variation of reality.
There's also that deleted detail about him reading to the elderly woman. In the movie, he's learning piano and ice sculpting, cool party tricks.
Right.
In the script, he's reading trashy romance novels to this old lady because he's already finished all the classics. It implies he has been there for, how long?
That's the big debate. In Rubin's original concept, he imagined it as a lifetime, a literal lifetime, maybe thousands of years, repeated in a single day.
But the studio, Columbia, and the director, Harold Ramis, they needed a redemption arc.
The classic Hollywood save the cat moment. They had to make him likable.
Exactly.
They pushed for the story to be less about the existential horror of eternity and more about a guy learning to be nice. Ramis and Rubin actually debated this deep philosophical question. Should Phil be like a bodhisattva?
Someone reaching a state of nirvana and enlightenment.
Or just a guy realizing he's kind of a jerk?
And Ramis won that battle. He wanted the comedy. He wanted the romance. But, looking at the production logs, the comedy on screen was masking some really serious drama behind the scenes.
Oh, it was heavy. We tend to think of Bill Murray and Harold Ramis as this dynamic duo Ghostbusters stripes,
The dream team.
but Groundhog Day actually broke them.
Murray was going through a really rough time during filming, wasn't he?
He was in the middle of a really messy marital breakdown, a full-blown midlife crisis. And the sources describe him as being irrationally mean and unavailable on set. He literally wouldn't speak to Ramis. He would only communicate with, grunts or just silence.
Can you imagine trying to direct a comedy when your lead actor is just grunting at you?
It destroyed their friendship. They didn't speak for 21 years after the film wrapped. It's tragic, really. The movie is about connecting with people.
Yeah.
And yet the creation of it drove these two best friends apart.
It's just so ironic. You have this movie about a man forced to repeat the same day until he gets it right.
Starring an actor who felt trapped in a life going wrong.
Who couldn't fix his own reality.
Life doesn't give you a do-over button.
Exactly. We don't get a loop. But that brings us to the second half of our mission today. We've looked at the fiction of the loop, because now we need to look at the reality.
Right.
Because according to the stack of physics papers you sent over, the universe might actually allow for a do-over button.
It allows for the button, sure. But pressing it is a lot harder than waking up to Sonny and Cher.
So let's break this down. Is time travel actually against the law?
The law of physics? No. And that's the big surprise. According to Albert Einstein's special relativity, time travel isn't just possible. It happens every single time you move.
Okay, let's unpack this slowly.
Yeah.
Because we always hear that nothing can go faster than light.
Right, 186,000 miles per second. That is the universal speed limit. But Einstein's big insight was that space and time aren't separate things. They're one fabric. Space-time.
Space-time.
And everything in the universe is moving through this space-time at that exact speed limit.
Wait a minute. I'm sitting in a chair. I'm definitely not moving at the speed of light.
You are. You are. Think of it like a budget. Everything, you, me, this table, has a fixed speed budget to spend. And that budget is the speed of light.
Okay, so I have a wallet full of speed.
Right. And you can spend that speed in two directions. You can spend it moving through space, or you can spend it moving through time.
Ah.
If you are sitting perfectly still in your chair, you are spending 100% of your budget on time. You're traveling into the future at maximum velocity.
Okay, I think I'm with you.
But the moment you get up to walk to the kitchen, you have to divert some of that budget. You take some speed out of the time envelope to pay for your movement through space.
So because I'm spending speed on movement, I have less speed left over for time.
Yes, exactly. You literally travel through time slower than the person you left sitting on the couch.
I love the analogy from the source material here. The Slim and Jim one at a drag strip.
Yeah, that's a good one.
So you've got Slim in a new Trans Am, and Jim is just standing on the sidelines with a stopwatch.
Right. Now, at normal speeds, like 100 miles per hour, the difference is so tiny you'd need an atomic clock to see it. But if Slim could drive that car at, say, 87% of the speed of light.
Which is about 580 million miles per hour. That's a fast Trans Am.
A very fast Trans Am. If he goes that fast, he is using up a huge chunk of his speed budget just to cover distance. He has very little left for time.
Okay.
So, Jim, standing still, looks at Slim's car. First, he sees the car physically shrink. It's called Lorentz contraction. It would look like it's only 8 feet long.
A little compact Trans Am.
But stranger still, Jim looks at Slim's watch, and he sees it ticking half as fast as his own. Slim is literally aging slower because he is moving faster.
So speed acts as a brake on time.
Precisely. And this isn't just theory. We've proved it with tiny particles called muons. When we accelerate them to near light speed in a lab, they live 10 times longer than they do when they're just sitting still. They are, in a very real sense, time travelers.
But this gets tricky with that George and Gracie scenario mentioned in the notes.
Right.
Because if I'm in a spaceship and I see you fly past me, I think you are the one moving, but you think I'm the one moving.
That's the relativity part of it. There's no absolute rest. If George and Gracie are just floating in empty space and they drift past each other, George looks at Gracie and says, "Hey, your clock is slow."
Gracie looks back at him
and says, "No, your clock is slow."
So, who's right?
They both are. From their own perspective, they are stationary and the other person is moving. It breaks our intuitive idea that there is one single master clock for the whole universe. Time is personal. It depends on your motion.
So that's speed. But the sources also talk about the tornado ride. This is where gravity comes in, with general relativity.
Yes. 10 years after special relativity, Einstein added gravity to the mix. He realized that gravity isn't a force pulling you down, it's a warping of space-time itself.
And the analogy here is that spinning amusement park ride, the tornado.
Exactly. Imagine a big spinning ride. If you are on the outside edge, you are moving faster and feeling more gravity than someone sitting in the center.
So if I'm hanging onto the outer rail of the spinning ride, feeling all that G-force, my clock is doing what?
It's running slower. Gravity or acceleration, it warps time just like speed does. The stronger the gravitational field you're in, the slower your time passes compared to someone way out in deep space.
So if I hang out near a black hole for a bit,
You are essentially pausing your time while the rest of the universe fast forwards.
that is just mind-bending. The sources also mention the bullet cluster in relation to this.
Yeah, that's a great piece of real-world evidence.
Yeah.
The bullet cluster is this massive collision of galaxies where we can actually see dark matter separating from normal gas. It proves that these huge gravitational fields exist and they really do warp the space around them, which confirms that the conditions for warping time are out there.
Okay, so we've established that time isn't fixed. We can bend it with speed, we can squash it with gravity. But Groundhog Day isn't about slowing down time, it's about a loop. It's about going back.
Right.
And that brings us to the big headache, the paradoxes.
Grandfather paradox.
The classic.
If I go back in time and kill my grandfather before he meets my grandmother, then I am never born. But if I'm never born, I can't go back to kill him. So he lives, so I am born, and my brain hurts.
This is the causality nightmare. It suggests that backward time travel just shouldn't be possible because it breaks logic, but
Yeah.
our sources provide two really compelling solutions. Okay, solution A, the multiverse.
Right. The many worlds interpretation, which was championed by a physicist named Hugh Everett. This idea says that when you go back and, pull that trigger, you aren't changing your past. You are creating a branch.
World A and World B.
Exactly. You come from World A, you travel back, and the moment you arrive, you create a new timeline, World B. In World B, you kill your grandfather. You are never born in World B. But you, the time traveler, are fine because you came from World A, which is untouched.
Okay, hold on. If I create World B and kill my grandfather there, I haven't really changed my past, have I? I've just ruined some other timeline.
That's the big criticism. It solves the logical paradox, but it fails the emotional test. You can't fix your own mistakes. You can only go to a new world where the mistake hasn't happened yet.
That feels like cheating. That's not a time loop, that's just dimensional tourism.
Dimensional tourism is a perfect way to put it. You're a tourist in a reality that isn't even yours.
But there was another solution in the sources, one that doesn't need infinite universes. It was a study from Vanderbilt University about entropy.
Yes, by Lorenzo Gavesino. This is fascinating. He uses thermodynamics, the laws of heat and disorder. Usually time has an arrow because entropy always increases. Things break, eggs scramble, people age. You can't unscramble an egg.
Right.
But Gavesino suggests that if a closed time-like curve, a time loop, actually existed, quantum fluctuations might fix the paradoxes.
Fix them how? Like the universe self-corrects.
Essentially, yes.
Yeah.
The study suggests the timeline would sort of heal itself to remain self-consistent. If you try to go back and kill your grandfather, the gun jams.
Or you miss.
Or you trip and break your leg.
The universe basically conspires to prevent the paradox from ever happening.
So that the loop can exist without breaking the laws of physics. It feels a lot like fate, doesn't it?
It sounds exactly like Groundhog Day. No matter what Phil does, he wakes up at 6 a.m. He can't break the cycle.
Precisely. You are free to act, but you cannot change the outcome.
So we have the theory. But how do we build the machine? The sources mention a specific device called a Tipler cylinder.
This is a genuine solution to Einstein's field equations. It was discovered way back in 1936 by Van Stockham and analyzed by Frank Tipler in the 70s.
What does it look like?
Imagine a cylinder. Very, very dense. And this is the big catch. It needs to be infinitely long.
Infinite. That's a lot of aluminum.
Or if not infinite, it needs some kind of exotic negative energy to make the math work. But think of it this way. Imagine you have a cup of coffee.
Okay.
And you put a spoon in the center and start spinning it really fast.
The coffee starts swirling around.
The coffee is space-time. The spoon is this massive, dense cylinder. If you spin that cylinder fast enough, like half the speed of light, it doesn't just spin in space. It grabs the fabric of space and time and drags it along for the ride.
Like the vortex in my coffee cup.
Exactly. There's a process called frame dragging. And if you are in a spaceship and you fly into that vortex in just the right spiral, the math says you will end up back where you started but before you left.
You're riding the swirl back to yesterday. The sources mention this pops up in Star Trek and Doctor Who.
Yeah, the TARDIS is sometimes linked to this concept. It's the most mathematically sound description of a time machine we have.
But there's that infinite catch,
Yeah. The math only works perfectly if the cylinder is infinitely long.
which is a bit of a problem.
It's a huge problem. And that seems to be the running theme. The universe allows time travel in theory, but in practice, it puts up these massive barriers. Infinite cylinders, negative energy, deadly radiation.
It's like the universe really doesn't want us messing with the past.
And yet we're obsessed with it in our stories.
That's the synthesis, right? Looking at Groundhog Day and these physics papers side by side. In fiction, the loop is a moral test. It's about character. Phil Connors has to become a better person to break the laws of time.
Exactly. In the movie, the how doesn't matter. We don't care how Phil is stuck, we care why. But in physics, the how is everything. And what's interesting is that while the movie uses the loop to teach Phil to appreciate the moment, special relativity teaches us that the moment is kind of an illusion.
How so?
Because if time is relative, if your now is different from my now, depending on how we move, then the past, present, and future are all equally real. They're all just coordinates on the map of space-time.
That is a very provocative thought.
It really is. We think of the past as gone, like smoke, and the future is unwritten. But physics suggests the future might already be there, just waiting for us to arrive.
So in a way, Phil Connors wasn't trapped. He was just stuck on repeat at one particular coordinate.
Right, and thanks to relativity, every time you get up and walk across the room, you are traveling into the future at an infinitesimally different rate than the person sitting on the couch. You are shifting your position in time.
So we're all just Slim and Jim drifting through the universe at slightly different speeds.
We are. We are all time travelers. We just only have the gear to go one way.
Well, whether you're stuck in a loop or just moving forward 1 second at a time, I think the lesson from both the physics and the movie is pretty clear. It's about attention.
Right.
Bill Murray, the actor, was miserable because he was focused on what was wrong in his life. Phil Connors, the character, was miserable because he wanted to be anywhere else. But eventually, he learned to just be there.
He stopped fighting the time he had.
I want to end with a quote from that original Groundhog Day script, which I think sums it all up better than any equation ever could. Phil says, "You can waste time, you can kill time, you can do time, but if you use it wisely, there's never enough of it."
Beautiful.
Thanks for diving deep with us. We'll see you in the future.